How the space-time bubble could work in real life. Step 1. Creating the space-time bubble. Imagine you're in a lab surrounded by the hum of high-tech equipment. You're about to create a space-time bubble, a region of space where the normal rules of time and space no longer apply in the same way. 1. Magnetic field generation. To create the bubble, you first activate powerful superconducting magnets. These magnets are not ordinary. They're designed to generate extremely strong magnetic fields. Think of these magnets as a super-powered version of the magnets we use today, but they're capable of altering the fabric of space itself. The moment the magnetic field is applied, you begin to see something extraordinary. The magnetic field lines start interacting with the surrounding space, creating a force field. This field doesn't just push or pull in a regular way, it begins to bend the fabric of space-time around it. Just like how a heavy object causes a dip in a trampoline, the field forms a bubble around your test area. This is a space-time bubble, the starting point for creating faster-than-light travel. In simple terms, you're essentially creating a pocket of space, where normal space-time no longer behaves the same way. This bubble is now a protected zone where the traditional laws of physics can be manipulated. 2. Negative energy, stabilizing the bubble. To keep the bubble from collapsing, you need something called negative energy. This isn't something we can see or touch, but it exists due to quantum mechanics, a weird property of tiny particles that allows them to exist in multiple states at once. Negative energy has a counteracting effect on gravity. It behaves oppositely to the energy we usually think of. In our case, we use negative energy to hold the bubble stable and prevent it from collapsing under its own force. It's like using anti-gravity to keep the bubble from bursting. Step 2. Making the bubble move. Now that the bubble exists, the next step is to make it move. Instead of using rockets or conventional propulsion systems, this bubble uses the fabric of space-time itself to move. 1. Space-time manipulation. The key to moving the bubble is manipulating space-time. Inside and around the bubble, with the magnetic fields and the negative energy, the bubble creates a local distortion in space-time. This distortion acts like a slingshot or warp drive that allows the bubble to glide across space. When the bubble is formed and activated, time and space inside the bubble behave differently from outside. Distance inside the bubble can be compressed, meaning the bubble could travel vast distances in an instant. Essentially, you're bending space in such a way that the distance between 2 points becomes shortened within the bubble. 2. Quantum effects. Now, here's where it gets fascinating. The particles inside the bubble are no longer behaving like regular particles. They are subject to quantum superposition and quantum entanglement. What does this mean? Superposition. Particles inside the bubble can exist in multiple states at once, meaning they can be in 2 places at the same time. This ability allows the bubble to maintain its stability and adjust its course in response to environmental factors. Entanglement. Particles inside the bubble are entangled with each other, which means that any change in one particle affects all others instantaneously. This helps the bubble's internal forces remain coordinated, ensuring that the space-time bubble remains intact as it travels. These quantum effects are like magical forces inside the bubble, helping to stabilize it and move it at super speeds, without violating the laws of physics. Step 3. Propulsion using the universe's energy. Now here's where the real magic happens. Once the bubble is formed and stable, it can push off from the universe's energy, like a boat floating on water using the currents to move. The energy inside the bubble taps into the fabric of space-time, and this interaction generates propulsive force. This force comes from the universe itself, a sort of cosmic wind that allows the bubble to travel at incredibly high speeds. Since the bubble isn't bound by traditional space-time, it can theoretically skip across the universe, bypassing normal distance, limitations, and bending space to make instantaneous jumps. Step 4. Faster-than-light travel. So, how fast can the bubble go? The beauty of this system is that speed is no longer constrained by traditional space-time limitations. With the ability to compress distance and manipulate time, the bubble could move faster than light. In fact, the bubble wouldn't actually be moving through space in the traditional sense. Rather, it's bending space around itself, allowing it to instantly appear in distant parts of the universe. Think of it as creating a shortcut through the universe. Instead of traveling directly through space, you're folding space so that you can travel from one location to another without actually moving through the middle part. In simpler terms, it's like folding a piece of paper so that 2 points on the paper touch each other without the space between them. Step 5. Stabilizing and controlling the bubble. To make this all work in real life, the system needs to remain stable and be controlled effectively. Here's how it's done. 1. Energy. Input. The bubble requires continuous energy to maintain, the magnetic fields and negative energy that keep it stable. This energy can come from a variety of sources, but in the long term, we could potentially use quantum field generators or advanced energy systems. Inside the bubble would need an advanced control system, likely based on quantum computers, to adjust the bubble, its trajectory, and ensure that it stays stable as it moves. In summary, 1. Create the bubble. Use superconducting magnets to generate a magnetic field, creating a space-time bubble. 2. Stabilize the bubble. Use negative energy, Casimir effect, to keep the bubble from collapsing. Manipulate space-time. The bubble uses quantum effects, like entanglement and superposition, to bend space and travel at incredible speeds. 4. Energy source. The bubble taps into the universe's energy, allowing it to move without traditional propulsion methods. 5. Faster than light travel. By bending space-time, the bubble can travel faster than light, potentially taking us anywhere in the universe almost instantaneously. How this is possible? The fundamental concept of using magnetic fields to influence space-time and quantum mechanics to stabilize the bubble is already supported by current scientific theories, such as general relativity and quantum field theory. The idea of dark energy and negative energy has been theorized, and quantum entanglement and superposition are well-documented phenomena. Though current technology may not yet allow for practical experimentation, the concept is theoretically sound, and simulations will help us validate it further.